Hello and welcome to the Daily Space for today, Monday, April 13th, 2020. I am your host, Dr. Pamela Gay, and I am here to put science in your brain. Mondays are the day that Nature Astronomy comes out, and while there are weeks that the journal doesn't carry a lot of stuff that we're going to highlight here on the Daily Space, this is not one of those weeks. We have 3 great stories, and our first one, starts with a bang. Astronomers from the Harvard Smithsonian Center for Astrophysics have announced the discovery of the newest supernova to hold the brightest ever known adjective set. To be fair, as long as we keep building larger telescopes that peer out into more and more of the distant corners of the universe, we're going to keep finding new, bigger, smallest, name the adjective. We're going to find it because we're looking at new volumes of space. But for now, we have a new object that is more extreme than has ever possibly been seen, and it's kind of cool, so we're going to talk about it. This particular supernova, SN 2016 APS, was found using the Pan-STARRS system. That is redundant. No matter what I say, it's going to be redundant. Pan-STARRS is a telescope that is doing a survey, and it is a system that is doing it. It's a long acronym. Let's just say Pan-STARRS found this thing. And since it was discovered, the researchers on this paper have been taking both follow-up observations to look at it in new techniques, look at it spectroscopically, look at it in new wavelengths, and they've also pulled archival data going back to 2015 where they were able to recover the supernova just as it was beginning to get brighter and brighter. Now, in trying to understand this system, they've realized that, to create this massive of a supernova, the progenitor to SN 2016 APS had to be massive, at least 100 times more massive than our sun. Now, this doesn't mean that the star that made this supernova had to start out that big. And in fact, the science team thinks that it wasn't one star that led to this particular supernova, but rather it was 2 separate stars that merged together. The reason that they're able to speculate this is when they observed the star using a spectrograph that allowed them to look at the atomic fingerprints of the different molecules and atoms that make up this supernova remnant. They found a whole lot of hydrogen, and in general, truly massive stars aren't going to have a lot of hydrogen by the time they go supernova. Rather, they think that what happened is 2 kind of massive stars merged together, in the process creating a massive envelope of debris that the supernova light could slam into, and creating one massive star that still had the amount of hydrogen that is more consistent with, one less massive star. Early in our universe, star formation was much more common. Large stars were much more common. And these kinds of mergers of somewhat massive stars were probably also much more common. This means that we can look forward to seeing more and more latest, largest supernova ever found, probably right up until the Large Synoptic Survey Telescope at the Vera Rubin Observatory turns on itself. That system, as it peers through the sky every 4 nights, is designed to find asteroids looking to destroy our planet, but it's also designed to find supernova just like this. So I suspect once we have that observatory around, we may finally discover the biggest, brightest object that's able to hold on to its title for more than just a few years. Now, this proliferation of survey telescopes is helping us quantify many different kinds of stuff that fill our sky. Instead of just targeting individual objects that we know are scientifically interesting, scientists are now using different telescopes scattered about the world to systematically observe large swaths of the sky in deeper and deeper faintnesses and in higher and higher resolutions. Recently, we've started to turn up interstellar invaders, asteroids, comets, objects that are visiting us from other solar systems. Asteroid Oumuamua is one of those objects, and it is perhaps the most famous of these objects, in part because it was the first, and also in part because of its really weird shape that has been described as both cigar-like and needle-like, and has led to a great number of comparisons to the spacecraft in Rendezvous with Rama. Now, we just haven't seen anything this long and skinny before, not in our solar system. And it sometimes seems that a spacecraft is just as valid an idea to explain this as any other idea. Although I'm here to say that, well, it's much easier to imagine how you get a spacecraft that shape than an asteroid that shape. This is probably the least probable way that you get this object. But while we acknowledge that spacecraft are not probable, trying to figure out a way to get an object this shape has been hard to come up with. But one team did manage to find a way. Led by Yon Jiang, it's postulated that as Oumuamua passed near its original host star, it got tidally disrupted and strung out into a long, elongated cloud of debris. And this process was likely part of what sent it on the escape velocity from its star system that allowed it to eventually enter our own star system. And one of the awesome things about it is it was this tortured, stressed out, shattered asteroid that was taken beyond its breaking point, that was eventually able to gravitationally come back together to chemically reform its bonds and become a new object once again. And that new object is what got to us, turning this perhaps into a fable that sometimes you have to undergo hard times and pain to accomplish something amazing. And that may be a message we really need today. Okay, setting all of that morality aside, here is a simulated image they were able to come up with by taking a single, everyday, regular asteroid, flying it too close to the sun, its sun, not ours, and then seeing how it comes back together. It's kind of amazing how much they were able to recreate what we know of Oumuamua's shape. Now, on to our last story of the day. I'd like to share that astronomers at Leiden University, working in a laboratory, no computer models were harmed, no telescopes were used, have been able to create methane ice in an artificial environment designed to recreate the situation in interstellar molecular clouds. In this containment system, they created both the ultra-high vacuum that is seen in space, as well as the necessary low temperatures. In this case, they got their system down to negative 263 Celsius, which is minus 442 Fahrenheit, or a whopping 10 degrees, or whopping 10 Kelvin. So now we get to see how you can evolve molecules in space while doing it in a laboratory. And that's kind of cool. And that's really all I've got for today. This has been The Daily Space. I'm your host, Dr. Pamela Gay, and I wrote today's episode. This episode will be produced by Susie Murph, and we are a product of the Planetary Science Institute, a 501c3 nonprofit dedicated to exploring our solar system and beyond. We are here thanks to the generous contributions and volunteer efforts of people like you. It is your bits, your subs, your patronage at patreon.com that allow us to, pay Susie and Annie to do all the episodes and amazing content they do around here. please consider giving if you are able. And if you aren't and you have some spare time, please consider getting involved in our various efforts. So check it all out over at CosmoQuest.org. I am now going to hang around to answer your questions. So please stick them in the chat. And I'm going to pull that supernova back up because that's a prettier picture. Thank you, Bad Panda, for the sub. Thank you so much, Bad Panda. Yay. Yay. Thank you. I have a dog. I have a dog that will not appear on camera. Let me see if I can at least work on training him to go over to the dog bed. I have Malachi down here with me. Oh, he's right here. Can you come here? Can you come here? Maybe? He's like, no, just throw it over here. And then he failed to catch. Thank you, Lancey, for the 100 bits. Thank you so much, Lancey. Dog right off the camera. Come here. Come here. He's like, no, I will not come to you. That is a confined space. Thank you. You put our rocket in an Easter basket. That's kind of amazing, Bad Panda. All right. So Raj Luthra asks, what type of a star stretched Oumuamua? So you can have this effect with pretty much any kind of star that is on the main sequence. I say this because if you have a giant star, the gravity at its surface is significantly less, and you basically have to fly through the star before you get the necessary tidal forces. So a star that's hanging out on the main sequence is going to have the kind of surface gravity that means you can get close enough to it to tear yourself apart. Necessary orbits and distances will vary. Hanny asks, does anything interesting happen when the stars are mixing after they merge? It depends on who you ask. If you ask an extragalactic astronomer, they're going to be, no, it's just a bigger star. If you ask a stellar astronomer, they're going to be like, oh my God, the physics that's going on in that core, it's amazing as the two cores merge. And so yes, there's some pretty darn complicated, interesting physics going on inside the core of that new object. Lots of mixing, lots of reassembling of how the internal structures of the star work. But overall, given how interesting so many things are in our universe, interesting is in the eye of the beholder. Fenmil asks, so this recombining could explain the lack of volatiles? Yes. So if you shred an asteroid or a comet near a star, it is going to lose, outburst all of its oxygen, nitrogen, other things that sublimate readily. We saw this with Comet Atlas breaking apart, I think it was last week, where there is a much expansion of its coma as it had a really bad day and broke apart. So yeah, we could have a bone dry Oumuamua because of this past shredding that let loose all of the volatiles trapped within the rocks. Smash two cakes together and ponder. Dave Killian's, that seems like an awful waste of cake unless you do it while wearing nitrile gloves and have the cake fall onto something that you can eat off of later, in which case go for it. It could be fun. Can I recommend doing this with two cupcakes that you can fling together with greater velocity? It's easier to throw cupcakes than actual cake. Could this be the reason for Oumuamua's reddish color? That I don't know, Hanny. That I don't know. Let's see what else is in here. I'm scrolling back now. Bad Panda asks, would this theory mean Oumuamua is a rubble pile like Bennu? So it depends on how much it got disrupted. So both Bennu and Ryugu in our solar system appear to be gravel piles, rubble piles, piles of boulders with rubble, with gravel, with dust. They likely formed through collisions where things got smashed. If you're tidally disrupting something, there's going to be a whole lot more heat involved when that something is a star. So what I don't know is how much things have, over the fullness of time, had the ability to do a combination of essentially cold welding themselves together and getting melted back together. So yes, rubble pile, but the question is, has that rubble pile been modified to turn it into something that is more chemically held together? Scrolling back. So AstroWise is asking, where is this supernova in the sky? Would it be visible with the backyard telescope? So pan-stars, a lot of things that it finds are temporarily visible with backyard telescopes, but since the supernova went off in 2016, at this point, it's faded too much to possibly be seen. Let me pull up its location, though. Pardon me while I type for a moment. It's 3.6 billion light years away. And still trying to find its position. For some reason, its position, I would have to pay $9 to tell you its position, I am afraid to say. So I can't tell you where it is on the sky. I'm sorry. Silly data behind paywalls. Silly data. All right, so that was all of the prior questions. So Raj asks, how bright was the nova? How is this different to a supernova or hypernova? So this was still a supernova. Hypernova involve massive magnetic fields, and you have to have something that's spinning quite rapidly. This could have been a hypernova, which is a subclass of supernova, but I don't believe the necessary gamma ray burst was observed to diagnose that. This could be due to alignments. If a gamma ray burst goes off and the burst is through the plane of the sky instead of directed at us, we'll never see the gamma ray burst. But I don't know. So basically, hypernovae are a class of supernovae associated with gamma ray bursts. Annie writes, since we are all at home, making a large cupcake collider could be a fun project, especially if you have kids. So in my brain, I'm not going to lie, you take 2 potato guns, and instead of putting potatoes in them, you put cupcakes in them, and then fire. It could be fun. It could be fun. Yeah. These are ideas. Not necessarily good ideas, but they're ideas. Any other questions out there? I have to admit, I, like so many other Americans, and I don't think this is a thing to the same degree in other countries. Like so many other Americans, I now have a sourdough starter. Its name is Groot, and it comes from Bobby at Annie's house. Annie's supernova, or sourdough bread. Annie's sourdough starter is named Bobby, and mine is named Groot. And it is going to get, in part, turned into sourdough muffins with cranberries and walnuts later today. Keeper writes, I think your neighbors would have strong feelings about you setting up multiple potato guns. So the one set of neighbors, their house is for sale and they're not living there. The other neighbors have kids and they might totally get into this. Annie's sourdough starter is named Bobby. Oh my goodness. I'm so not yet. It's Monday, people. It's Monday the 13th. Ms. Britt Kitten writes, Comet Atlas was supposed to be really bright. Then it peaked and broke up. That was a sad day for me. It was a sad day for me too. Yeah. So in the 90s, we had both Hyakutake and Hale-Bopp. And they were both glorious and large and easy to see. And we need something like that. So Dave Killians is like, my goal, cupcake achieving escape velocity. I'm not sure cupcakes have the structural integrity to survive max Q. Astro Wise writes, my starter's name is Cyril, and he's a good boy. Oh, man. So Raven Lillian, Hale Bopp was actually spelled, Hale is in the name, Hale, Hall. And then I think Bopp was a second person. Let me confirm it, but I know it. Hale Bopp Comet. Yeah, it's two different humans. The most bright and tragic comet of the 1990s is how Space.com describes it. Hale Bopp was unusually bright when... Stop. Hale Bopp was an unusually bright comet that flew by Earth, reaching its closest approach to the planet in 1997. It was most spectacular in the Northern Hemisphere and visible to the naked eye for 18 months. I have to admit that this is when I was working on my master's thesis, and the drive from the Odessa airport out to McDonald Observatory had Hale Bopp in my windshield almost the entire drive, and it was super distracting and awesome. All right. So I think that's all I've got for today. I am going to record the podcast. I am going to make lunch. In theory, I may have a business phone call I have to take, and I do have a telecon I have to take, because I swear to God, the extroverts are creating telecons because they need humans. Other than that, I'm going to try and work on software today. So those of you over in the Coders Den will hopefully get a lot more of my attention, depending on how the phone call and telecon goes. Anyways, lunch is going to be, I cooked a whole bunch of potato lamb keema curry a couple weeks ago and froze a bunch of it in like single serve containers. So I am going to have lamb potato keema curry made from scratch by me. Probably on pita chips. I think I'm too lazy to make rice today, but I know we have a box of pita chips. We will see. So that's the plan. So thank you for the follow, Haskelltron or Haskelltron. I don't know if you're a Haskell or a Haskell. So yeah, I am now going to figure out what the magic combination of buttons is that will allow me to run the credits in just a moment. And while I am pulling that up, do you guys have anyone you want me to raid right now? I'm always up to new ideas on who to raid. I'm looking to see who on our raid list is open at the moment. Oh, Keeper of Maps is checking. I'll just wait for Keeper of Maps. DPI 209 comments. Orbital Battle Cupcake. Sounds like the name of a Japanese girl band. I would totally listen to that. I would totally listen to that. Not going to lie, I have been binge watching Cupcake Wars and the Halloween Baking Championship from the Food Channel. And it has inspired me. There shall be photos of various cupcake shaped things in my Instagram feeds future. All right. Timber Anew is streaming. Okay, so I'm going to set up a raid of Timber Anew. Who is making and crafting. So please give Timber Anew a fabulous CosmoQuest launch off. All the rockets out, please. All the rockets, rovers, and helmets off. But for now, this has been The Daily Space. I am your host, Dr. Pamela Gay, and I wrote today's episode. Susie Murph will be doing production, and we are a product of the Planetary Science Institute, a 501c3 nonprofit dedicated to exploring our solar system and beyond. Thank you all so much for being here. Thank you for all you do to support us. It is because of you that we are able to pay Susie and Annie a living wage. So thank you. If you would like to support our show, the best way you can support us is on patreon.com/CosmoQuestX. And that's it. That's all I've got. Wherever you are in the world, have a fabulous morning, evening, or afternoon. And I will see you on the other side, and wash your hands.